I know we talked about interest really briefly, right? But some of you might not know that when you look in your bank account, when you get that interest paid, that's not actually once a year. They're a bit nicer than that. They say, okay, instead of paying you once a year, if you look into your account every month, that they should give you that interest amount. If you've seen your bank account much, and it's in the fine print that everybody reads, but they don't really read. So let's say the interest rate on the account is 6% per annum and is paid monthly, okay? So that's actually given to you in the fine print there, right? How do we adjust for this? Because we actually have to adjust for this in the calculations, right? This is something that we call compounding periods. And that's why when I was looking at my compound interest formula, A equals to P outside of 1 plus R to the power N, I didn't say N was the number of years. I said N was the number of periods because they don't always pay it out each year. In most cases, most banks will pay it out monthly. We actually have to adjust for that in our calculations, okay? The rate then has to be adjusted. It's the interest rate divided by the number of periods each year, okay? And then the number of periods, well, that's just the number of years times how many periods in a year. Oh, I can't write that. Right? So let's just recap that, right? Because they don't actually pay the interest just once a year, the calculation is slightly different now. We have to say, okay, if I'm paying it each month, how do I account for that? Right? Well, I have to take my normal interest rate, divide by the number of periods each year, and then, well, the number of periods, well, I'm going to have to take the number of years I have and multiply by how many periods there are in a year. Let me give you a quick example of that, right? Let's take that same question that I gave you in the first example, $2,000 at 5% for 3 years, but this time it's compounded monthly. So I'm paying it out monthly now. All the information is still the same, but you'll see that the result is actually slightly different, right? This time my rate, well, that's going to be 5% or 0.05 divided by the number of periods each year. Well, if it's compounded monthly, there's 12 months in a year, so that's divided by 12. Now, what about the number of periods? Well, that's just going to be 3 years multiplied by 12 as well, and that gives you 36, okay? So I'm paying it out each month now. Everything else is going to be the same. I'm just going to apply the formula in the same way. So I've still got my starting amount, 2,000, the principal, multiplied by 1 plus the rate, which is this guy here, divided by 12, all to the power 36. Can you plug that in for me? 322.94446. Let's go 94, okay? Remember, why am I doing the same example? Because I'm showing you that when I compound things annually and I compound things monthly, it's actually different. How much more do you get, Rhiannon?
Wait, I'm trying to figure out how much more you get. The last one was
$6, $7.
yeah.
About $7, right? Yeah, so hang on. We didn't change anything. All I did was I changed how often I pay it out, but somehow I have more money. This is actually a feature of compounding things more frequently. The more frequently you pay things out, the more money you'll actually get. And it doesn't seem like it's a big difference for, $6 or whatever, just because of how we've changed the compounding periods, right? That's the main feature, and the thing I want to highlight, that the more times we compound, the more times you pay it out, the more you actually get from that. Lucas, yeah.
How do you get it to be compounded monthly?
So banks will pay it out monthly, actually. Banks pay it out monthly. They determined that. They determined that. Does that make sense? Any questions about that?